Hi, what's up, guys? Today, let's look at the Lintcode problem number 11, search range in binary tree. So for a given two values, K1 and K2, where K1 less than K2, and a root pointer to a binary tree. So we need to find out all the keys of the tree in range K1 to K2. For example, print out all the x such that K1 less equals to x less equals to K2. And x is the k of a given BSD binary search tree, and return all the keys in ascending order. So let's look at the example. If K1, we specify the K1 and K2 to 10 to 22. Then for this below given binary tree, so our answer should be 12, 20, 22, because 12, 20, 22, they're right within this range specified by K1 and K2. So this is binary tree. I bet you definitely remember the characteristics of the binary tree, right? For binary tree, the left children is always, their key is always less than the root, and right children is always greater than the root. So that's the definition of the binary tree. For this given problem, so we have two solutions, and solution one is just purely traverse the whole tree, and we were able to loop through every tree node, and we just check if this tree node is within K1 and K2. If they are, then we just append them and return. So let's look at this solution one. So this is our entrance. We take three parameters. One is the given binary tree, one is K1, one is K2. So first we have to check the input parameters to see if they are valid. If the tree is empty tree, we're going to just return empty result. The answer, if the parameter is right, so we're going to just declare the answer list. We're going to just put all of our answers into this answer list, and here we're using the level order traverse to traverse this tree, because we're using level order. So here I'm going to just use Q. So in Python, I just use this list to represent the queue, but here we actually it's not really using the queue. It's just the queue concept, and we just keep adding the the elements into the queue. We're not really just pop out the data from the queue. So here we need to use another cursor, another variable. We call it index. This index is like a cursor to help us to access the elements in the queue. So the termination condition is when the index reaches to the last element of this queue, then this whole while is going to end. And remember that during this while loop, we actually constantly adding elements into the queue. So this is always changing, right? And also because we're using queue and we have to put something into the queue, to initiate this process. Usually we put the root into this queue. It's like a seed, all right? So once this is done, and we can just start this while loop. What does this while loop do? Actually, this while is gonna do two things. The first thing, actually, for this part is like a business. What we're gonna do using this queue? In the first way, actually, we're gonna just populate data, access the data in the queue through this way. A queue will give this index, then we can access the data in this queue. This is how we access the data. And we have to check this data if this data is within the range, grade equals to Q1 and also less equals to K2. If this element is, and we're going to put it into the answer. So this is the first part. This is our core logic, our business. And second part is that because we're using Q, and we always have to update the queue. Every time when we access the element, and we're going to update our queue. So we're checking the current element we're accessing. If this guy has the left children, and we're going to put its left children into the queue. if this guy has the right children, we're going to just put its right children into the queue. So queue's number, queue's elements is always just keep adding. And because we access this one, then we put this one's children into this queue. We access this one and put this one's children into this queue. So because we're in the queue order, so eventually this is a level by level traverse order. Okay, so after that is done, we actually checked every nodes of this binary tree, and we checked if they are within this range or not. So once this is done, we're going to just return and also remember that we have to update this index at each end of this while loop. So in end, we have to output put in the ascending order. So here we have to do a sort. So let's try to run this. Let me just mark this as 1. Okay, so we're going to just test this function. All right, looks great. So that's today's algorithm. So in the next video, I'm gonna just introduce the solution 2. Thanks. Have a good one.